Hello and welcome to yet probably the most important section in this unit, and this is section 6, and this is figures in the coordinate plane. Okay, so what we're going to do is we're going to apply some coordinate algebra proofs to triangles and quadrilaterals and be able to calculate the perimeter of a triangle or quadrilateral given the coordinates of the vertices. Okay, so just kind of a quick review on what we have as far as types of triangles. We have a scalene triangle where all three sides are different. Okay, all sides are different. Okay, we have an isosceles triangle, which means we have two congruent sides, and we actually have two congruent angles. Let me put that in there real quick. An equilateral triangle means that all sides congruent. Okay, and we know that all angles are 60 degrees, okay, and they're all congruent on here. Okay, a right triangle means that we have one right angle, okay, and the Pythagorean theorem exists on this one, okay. So what I want to do is classify this triangle to see what we have, okay, and let's take a look at the types of the lengths on here. And we use this thing called the distance formula, okay? And you can use that, but I prefer, and this is just derived from the Pythagorean theorem. So this is the same thing as the Pythagorean theorem. And so we're going to use that to help classify triangles and define side lengths, okay? And so what I mean by that, it's easy for us to find the length of CB. Okay, we can kind of just count those lengths. And we know that the CB has a length of 6 units. Okay, going from 0 here, counting to 6 here. All right, now we want to figure out what's the length of AC. Okay, and so what I want to do with that is I'm going to do this. I'm going to draw a triangle. So we want to find the length of AC. So I'm going to highlight that. And what I do on this graph is I make a right triangle. So I go from C to A, making a stair step, going straight up and straight over. Okay, so it's going to help us do a few things. When I draw this triangle, we can get the slope of AC, and we can also get the distance. So the one thing I need to do is label this side here, okay? And I know that that is a length of 4. So from 1 to -3, that's a length of 4. Okay, and then the length over here from 0 to 3, this length has a length of 3. Okay, and I kind of already know, I've created this right triangle here. The reason I'm doing that is because I want to use the Pythagorean theorem to figure out what AC is. And I already know that it's going to be 5, but let's just show that. Okay, so I'm going to do this. I'm going to say that length AC, okay, AC, I'm going to do this. I'm going to take the square root of my sides, which was 3 squared plus 4 squared. Okay, and I'm essentially doing the distance formula here. Okay, but I can kind of just get used to writing that. All right, and I get that, by doing this. I get that by saying, AC, that thing squared is equal to 3 squared plus 4 squared. All right, and if I take the square root of both sides, all right, then I get this here, that AC is equal to that. All right, so let's write that out. Let's write that AC, and let's do the math on this. We're going to get the square root of 3 squared, which is 9, plus 4 squared, which is 16. Okay, if I simplify this, then I'm going to get the square root of 9 and 16, which is 25. And so we get that AC has a length of 5 units. All right, so that's what I know, okay, that AC is length of 5. All right, now, on the other one, for AB, let's do that. I'm going to use blue, so I'm going to try and connect points A and B together. All right, and we're going to go over and down, okay? Now, I know that this length here, this top length here of this triangle has a length of 3, and then that this length here has a length of 4, and I'm just counting those, okay? Now, we've already done the math on this. Now, here's the cool thing. When you get a triangle like this, when you've already done this math and you say, okay, I'm going to find AC, and when you have a congruent triangle, when you have the same stair step, then you know that that you have a congruent segment here, that AB and AC are going to be congruent. So because I've already done that, and I would also encourage you guys to write it out. I'd say, all right, well, let's take a look at AB. All right, I know that's going to be the square root of 3 squared plus 4 squared. And because you've already done this math up here, you don't need to go through it again. Okay, you can if you want, but you don't need to. Okay, so I know that AB is going to be equal to 5 units as well. Okay, and so now, when I go over here and label this as 5, okay, that's all fine and good, but what I can do then is I can say, all right, AC is congruent to AB. All right, and I'm going to write that over here. Okay, I know that AB is then congruent to AC. All right, so since I have 2 pairs of congruent sides, all right, I know this is 5, and this is 6. What I now know is that, what do I got here? That I have an isosceles triangle. Isosceles triangle. Okay, and that's what I'm trying to figure out. What kind of triangle do I have? All right, but I have to use those coordinates. I have to actually physically measure those units out to get those lengths. Okay, now the other thing I need to do, I need to check to see if I have a right angle. Okay, and so what I want to do here is calculate the slope of AC. I already know the slope of CB is 0. Okay, so I know the slope of CB or BC is equal to 0, okay? And that's just a horizontal line. Remember how we calculate slopes, guys? I've got a positive slope, I've got a negative slope, I have a 0 slope, and I have an undefined slope, okay? And we think of slopes as rise over run, okay? Rise over run, okay? And so what I want to do here is calculate these slopes and see what we get. So my slope here of AC, okay, and I could use the slope formula. I could identify what these points are, but guys, I'm telling you, draw the picture, okay, draw your right triangle. We've already done that, so we already know how many units it rises up, which is 4, okay, so we get 4 over 3, okay, and that's the slope of AC, all right. Now, the other thing I know is we're trying to find the slope of AB. So this one's going to be negative. Okay, now, just because it's going in this direction and it follows this part up here. Okay, but my rise is 4 still. Okay, and my run is 3. Okay, so I rise up 4, go over 3. All right, but I have a negative slope. Okay, so these slopes are just opposites. Okay, they're not perpendicular. All right, so that's kind of the key. So we're looking to see if they're perpendicular. They are not perpendicular. So what I know is that we just have a regular isosceles triangle. If these would have been perpendicular, then we would have said that we would have had a right isosceles triangle. Okay? So, all right, let's talk about, jump over to quadrilaterals and see how we would do those. You can still use all those properties we learned about, okay, but when we're doing coordinate geometry, we really want to talk about diagonals, okay? And usually what you have is you'll have a picture of this, and you'll kind of already know what it is, but we need to verify what it is. So in a parallelogram, what I know is that the diagonals bisect each other, okay? The diagonals bisect each other. Okay? And so I'm going to draw in that picture here. All right? So if we can show that, all right, and we'll go through how to do that, then we have just an ordinary parallelogram. Okay? The rectangle, the diagonals are congruent. Okay? And that's what I know. And they also bisect each other, okay? So I know that all 4 of these lengths are the same, okay? In a square, the diagonals are not only congruent, okay? The diagonals are congruent, they are perpendicular, and they bisect each other. All right? And that's the idea, okay? in a rhombus, okay, we only know that the diagonals are perpendicular. So the diagonals are perpendicular and they bisect each other. All right, so we have that, or I know that. Okay, in a trapezoid, okay, I just know that two of my sides are parallel, but if we talk about the diagonals are congruent, all right, if it's an isosceles. So the diagonals are congruent if it's isosceles. All right. And then in a kite, my diagonals, my long diagonal, okay, is a perpendicular bisector of the other diagonal. So the long diagonal is a perpendicular bisector of the short diagonal. All right. And so there's other things we'll talk about. You need to know the other properties of these figures, obviously, but the diagonals is the important part. And that's how we're going to, show what we've got here. Okay, what type of figures we have. Okay, so on this one, we want to classify this quadrilateral ABCD. And to me, it kind of looks like we have a square. Okay. And so what I want to do is, and the ultimate end goal is to find the perimeter of this quadrilateral. Okay, so it wants us to find all the sides or all the slopes of each side, and we want to find all of the lengths of the sides. So what I'm going to do is I'm going to come in here and I'm going to draw in my triangles on the outside to show that what kind of figures we have. Okay, so if I look at points from A to B, okay, I need to think about the lengths there. Okay, I'm going to draw in the values for BC. Okay, and then I'm going to do the same thing for, let me get a different color for AD. All right, draw your right triangle. Same thing for CD. Okay, and draw your right triangle. Okay, so what this will do, this will help us figure out the slopes and it will help us figure out the side lengths. Okay, so now what I want to do, let's go back to AB. All right, this has this length, 1, 2, 3, 4, has a length of 4. Okay, and then this length, 1, 2, 3, 4, is also 4. Okay, so 4 by 4, and it's a right triangle. Okay, we'll do the Pythagorean theorem, but we don't really need to. We already kind of know it's going to be 4 root 2 based on a perfect isosceles right triangle. Okay, the other thing over here, let's do for BC. Okay, this is a length of 1, 2, 3, 4. Okay, and then this top part has a length of 4. Okay, so that makes a right angle. I know that this is going to be 4 root 2. Okay, let's go down to AD. All right, this one is down 4 over 4. Okay, and then for CD, all right, it's going to be 4 and 4. All right, so we already kind of know what we're going to have here. This is going to be 4 root 2. This is 4 root 2. Okay, and let's just go ahead and do that. So let's just take a look at AB first, the slope of AB. Now what I know about that is that AB, we go up 4 over 4. So and it's going in this direction, so it's positive. So for slope of AB, I'm going to come in here and say that that's 4 over 4, which is equal to positive 1. Okay, now let's go back and look at BC real quick. Okay, BC, we're going to go up 4 to the left 4, and we're going in this direction, so that means that we're negative. So I'm going to write that as negative 4 over 4, which is negative 1. Okay, and then for the last one, we've got we go same thing. We go we're going in this direction, so it's positive. We go down 4 to the left 4. Okay, so that's going to be a positive 1. All right, so this one's going to be 4 over 4, which is 1. Okay, and then AD is going to be 4 over 4, but it's negative, so it's going to be negative 1. All right, so we're going to be negative 4 over 4, which is negative 1. Now, what I know is that these are perpendicular, okay? So what I know is that is this, okay? 1 and negative 1 are opposite reciprocals. And let me put that up here. If I have 1 over 1, okay, my perpendicular slope is going to be negative 1 over 1. Okay, so if I have 1 is going to be perpendicular slope to negative 1. So these form a right angle, okay? Form a right angle. And so now with that, so then I can just come in here and say, okay, all of these angles are going to be right angles. Okay. On the next one, let's do this. So for AB, let me set this up as this. We're going to do the square root of 4 squared plus 4 squared. Okay, and that's going to give me the square root of 16 plus 16. Okay, which is going to give me the square root of 32. Okay, now if I simplify that, I can split that up into the square root of 16 times the square root of 2, and the square root of 16 is 4 square root of 2. Okay, so we can do it using Pythagorean theorem if you realize that, hey, this is a special right triangle. Okay, I know that these segments are congruent and they form a right triangle, then you automatically know this is 4 root 2. Okay, same thing over here. If these are congruent, you can make the same claim about 4 root 2. All right, if you do these two down here, they're congruent, so your hypotenuse is 4 root 2. And then down over here, these are congruent, so your hypotenuse is 4 root 2. So even though when you have all those same types of triangles, okay, you can just come in here and say, all right, well, BC is going to be 4 root 2, 4 times the square root of 2. All right. So 4 times the square root of 2. CD is going to be 4 times the square root of 2. And I know that AD is going to be 4 times the square root of 2. All right, so when you have those, and it's all just about you drawing these triangles, okay? And once you do that, then you can just kind of draw those and make those guesses, all right? So now what I want to do is calculate the perimeter of quadrilateral ABCD. Okay, so my perimeter is going to be 4 square root of 2 plus 4 square root of 2 plus 4 square root of 2 plus 4 square root of 2. All right, if I add all these together, that's actually going to give me, and when you add these together, you keep your, use combined like terms, kind of like when if they were all 4x, but I'm going to get 16 times the square root of 2, okay? And you can just plug that all into your calculator, but I'm going to do 16 times the square root of 2 and hit enter, and that's going to give us a perimeter of approximately 22.6 units, okay? And that's all we're doing, all right? So that's what we've got. Okay, let's go ahead and take a look at the next one. It says, prove that the diagonals of the square QRST with vertices negative 3, 5, negative 3, 5, negative 1, 3, negative 3, 1, and negative 5, 3 bisect each other, okay? So this one's a little bit interesting. If we're talking about bisecting, okay, then we're really talking about finding the midpoints, all right? And so the midpoints of this, remember we have the formula x sub 1 plus x sub 2 over 2, comma y sub 1 plus y sub 2 over 2. Okay, that's my midpoint formula. And so if we get a common midpoint, common midpoint means that they bisect each other. They're bisected, okay? Now, that's all that we're asked to do, okay? Prove that the diagonals of the square with these vertices bisect each other, okay? And so let's go ahead and do that. So let's go ahead and take a look at QS. All right. So QS, and this is the point, and we'll actually use the points for this one, is negative 3, 5. Okay, and S is negative 3, 1. Okay, so let's find the midpoint of QS. Okay, so the midpoint of QS is going to be, okay, let's take our X values and add them together and divide by 2. So I'm going to take negative 3 plus negative 3, and then we're going to divide those by 2. We'll take our Y values and do the same thing, 5 plus 1. Okay, so we get 5 plus 1 over 2. All right, and so what happens is we get the midpoints from those. All right, so if I evaluate this QS, negative 3 plus negative 3 is negative 6 over 2, comma, 5 plus 1, which is 6 over 2. And this is going to give us the midpoint of negative 3, comma 3. All right, that's our midpoint. All right, now what I know is that if we share a common midpoint, then we know that they're bisected. All right, so I'm going to come over here and let's do it for TR. All right, TR, let's do this one in blue. Okay, and so TR has the value of negative 5, 3. Okay, and this is the point negative 1, 3. So let's find the midpoint of TR. All right, let's add our X values together. So negative 5 plus 1. Negative 5 plus negative 1 over 2. And then 3 plus 3 over 2. All right, and so what we end up getting here is we'll get negative 5 plus negative 1 is negative 6 over 2, comma 6 over 2. Oh, look at that. Okay, so TR is equal to negative 3, comma 3. All right, and so because we share a common midpoint, okay, we have the same thing, negative 3, 3, negative 3, 3, and let's label that point here. Okay, that midpoint, negative 3, 3, is right here. Okay, and that's the idea, is that, you know, once we have that common midpoint, then we know, and a midpoint just cuts something in half. These are all congruent. Okay, we already know it's a square, but we just wanted to verify that those are bisected. Okay, now the other thing that we could do, it didn't ask for perpendicular bisector. Okay, so if it's asking for perpendicular, all right, then what we know is that it's the slopes are going to be opposite reciprocals. All right, and we know that this slope is undefined. It's vertical. This slope is 0. Therefore, that QS is also perpendicular to what do we have? TR. Okay, so if the diagonals are perpendicular and they share a common midpoint, then they are perpendicular bisectors. Okay, and that's the idea. All right, let's go ahead and take a look at the next page, the last page. All right, so we've kind of already talked about this, using theorems to prove the classification of special parallelograms, and I'm talking about using the diagonals. Okay, so remember that in a parallelogram, the diagonals are just going to bisect each other. Okay, but here the rectangles, or the diagonals, let's rewrite this down. Okay, diagonals just simply bisect each other. So the diagonals bisect, okay, but they're not congruent. All right, so I'm going to draw that here, drawing these diagonals. These are congruent, but these two are not. Okay, over here, all right, I've got these two diagonals. All right, the diagonals in a rectangle, diagonals are congruent, okay, and they bisect each other. All right, so then I know that these are congruent, and that's it. All right, so the diagonals themselves are congruent and they bisect each other, meaning they cut each other in half. Okay, in a rhombus, okay, for these diagonals, okay, we know that the diagonals are perpendicular bisectors. Okay, So I know that these are congruent, and we form a right angle. Okay, diagonals are perpendicular bisectors, but the diagonals are not congruent. All right, so that's what we've got. All right, okay, here, let's do this. We want to verify that this quadrilateral is a rectangle. Okay, so if we first want to prove that the quadrilateral is a parallelogram, okay? And so let's do this. What we'd want to do is just show that LP is parallel to MN and that they are congruent. And then we want to show that LM is also parallel to NP and that it's also congruent. So let's do that. We just want to show it's a parallelogram. So let's find, we want to do two things. We want to do slopes and we want to do distances. All right. So let's do the slope. Let's draw in our triangles first. Okay, let's draw in our right triangles. Let's do LP. Okay, over and up. We can make that look a little bit better. Okay. MN, okay, is over and up. And then PN, okay, over and up like that. And then LM, up and over. Okay, so let's do this. All right, let's come over here. Let's say that this is a 2, this is a 3, this is a 2, this is a 3. Okay, you can already show that MN is congruent to LP. Let's do the other ones. I know that this distance here, 1, 2, 3, 4. Okay, and then over 1, 2, 3, 4, 5, 6. Okay, and then I've got that this is going to be 6 and this is going to be 4. Okay, so what I want to do now is kind of show, okay, so we've got the slopes of LM. Okay, so we've got LM. What else do we have? MN. Okay. We've got NP. And then we've got PL. All right. So the slope of LM, the slope of MN, NP, PL. Okay, so we've got this. The slope of LM is going to be up 4 over 6. Okay, so LM is going to be 4 over 6, which simplifies to 2/3. Okay, that's our slope. Okay, now what I notice, okay, and it's positive, it's going in this direction. Okay, I also notice that about PN. PN goes in this direction, and we're going to go down 4 to the left 6, so same thing. Okay, this is going to be 4 over 6, okay, which is also 2/3. Okay, so those are the same. So that means that LM is parallel to NP. Okay, now the other thing I know is that, all right, we want to find LP or PL and MN, and this is going to be, these are going to be negative slopes, so that's good. We're going to be going up 3 over 2. Okay, so MN is going to be negative 3 over 2. Same thing with PL, it's going to be negative 3 over 2. All right, so because these are the same, all right, we know that they are parallel. Okay, so MN is parallel to PL. All right, and that's what I know. Okay, now what I know about that, MN is parallel to PL. You know, that's the first thing that I know. Okay, they're parallel. What we can also conclude here is that these are opposite reciprocals. Okay, so we can also conclude that LM is perpendicular to MN, okay, and PL. All right, same thing, you know, with NP. Okay, that's going to be perpendicular to MN and PL. Okay, so that's kind of making our case to showing that we have a rectangle, that this parallelogram is a rectangle. But let's go ahead and calculate the distances too. For LM, okay, so let me do this. LM and NP. Okay, let's figure out what those are. And then let's do MN and PL. Okay, let's figure out what those are. All right, so for LM, okay, this is going to be, LM is going to be equal to the square root of 4 squared plus 6 squared. So let's put that in here. So LM is going to be the square root of 4 squared plus 6 squared. Okay, and that's going to give me 16 plus 36. All right, which is then going to be the square root of 52. Okay, and a perfect square that comes out of 52 is going to be 4 and 13. So the square root of 4 times the square root of 13. Okay, and this is going to be 2 times the square root of 13. So that's the length of LM, is 2 times the square root of 13. All right, so now what I want to do, because NP has the exact same thing, a 4 by 6 right triangle, I don't have to do that math again. I can just jump in here and say that this is going to be 2 times the square root of 13. Okay, so then what I can conclude is that LM, okay, is congruent to NP, all right, because they have the same length, okay, because they keep getting the same thing. All right, so for MN, let's do that one. MN is going to be the square root of 2 squared plus 3 squared, which is going to give me the square root of 4 plus 9, which equals the square root of 13. Okay. Now, because I get the same thing for PL, this is going to be the square root of 13. Okay, because those are the same, all right, we can then say that MN is congruent to PL. All right, so we're just using, what we have to just show that all those are congruent. So let me write this in here, that this is going to be 2 square root of 13, that this one is the square root of 13, and this is the square root of 13. So we can show that these are congruent and that these two are congruent. All right, so now we want to show the steps to prove that a parallelogram is a rectangle, okay? So we've shown that we have, that these are parallel and that these are parallel, these are congruent, these are congruent. We've also shown that the angles form a right angle, okay, which is probably enough, but let's do the steps to prove that the diagonals, all right, so for a rectangle, the diagonals are congruent and they bisect each other, okay? So it won't take long, but what we have is this. All right, I'm going to come in here and I'm going to draw in my rectangle, my what are they called? The diagonals. Okay, so I've got LN. Okay, and this is going to be the point negative 5, 0. All right, and N is going to be the point 3, 1. Okay, so let's do that. Let's say LN. Okay, let's put that down here, LN, and that contains the points negative 5, 0, and 3, 1, okay? And then let's do another diagonal. Let's do PM, all right? So P to M, and let's draw that line. Okay, and so what I know, P is the point negative 3, negative 3. Okay, M is the point 1, 4. All right, so let's write that down. Let me write that over here. PM, and that's the point negative 3, negative 3, and then the point 1, 4. Okay, so let's take a look. All right, so let's do this. Let's find the midpoints first. Okay, so let's do the midpoint. See if they share a common midpoint. And then let's do that. All right, so we've got negative 3 plus 1. Okay, add the x values together. Over 2, comma, negative 3 plus 4. Let's add those together and divide by 2. So then we're going to get negative 2 over 2, comma, negative 1 over 2. I'm sorry, just 1 over 2, not negative 1 over 2. All right. So I end up getting the point -1, comma 1/2. All right. And that looks to be about right. -1, 1/2. Okay, seems to be about right there, which is kind of close to the intersection. It's not going to be perfect, but it should be in the ballpark. All right, let's do the same thing for the for LN. All right, so for that one, okay, let's find our midpoint. And it's going to be the same thing. Let's do -5 plus 3. Let's add our x values over 2. And then 0 plus 1 over 2. Add our y values and divide them by 2. All right, so then that's going to give me -2 over 2. Ooh. And this is going to give me 1/2. Ooh. And then -2 over 2 is going to give me -1. Ooh. And then we get 1/2. So we share a midpoint. Okay, so we share a common midpoint. All right? And if we share a common midpoint, then what happens is we know that the diagonals bisect each other. Diagonals bisect. Okay? And that's it. All right, so now what I can do, let's find the lengths of LN and PM. All right, so let me come in here and let's draw in that right triangle here, so that we can figure that out. This is a length of 1. This is a length from -5 to 3. That's a length of 8. Okay? So I'm going to come over here and say that LN, okay, has a length of the square root of 1 squared plus 8 squared. All right? Now I'm going to do the same thing for PM, and we'll see if we get a common value there. All right, so let me go over, whoops, wrong color, over and up. Okay, this is a length of 1, 2, 3, 4. This is a length of 1, 2, 3, 4, 5, 6, 7. Okay, so now here's what I know about PM. Okay, PM has lengths of 4 and 7. So PM is equal to the square root of 4 squared plus 7 squared. Let's see if we get the same thing out of this. All right. So if I do 1 squared plus 8 squared, that's going to give me the square root of 1 plus 64, which is the square root of 65. Okay, let's just leave it like that for now and see if we get the same thing for PM. PM is going to give us the square root of 16 plus 49. Oh, man. Those might add to 65. 16 plus 49 is 65, so we get that this is the square root of 65. So I know that these are the same, okay? And so because of that, I know that LN, okay, is going to be congruent to PM, okay? So what I know is that the diagonals bisect. They share a common midpoint, so they bisect, and the diagonals are congruent. Okay, so the diagonals are congruent. The diagonals bisect each other. That means that with these two things, you have a rectangle. Ugh. That's a lot of work. Okay, but it's computation, and it's just knowing, okay, what am I trying to find? I'm trying to find lengths, trying to find midpoints, and you're trying to find slopes. So we want to find lengths, okay? Length, which is distance, okay? We want to find the slopes, okay? And then we want to find midpoints, okay? And I do this all by drawing triangles, okay? And then just analyzing from there. So I know it's kind of tricky, I know it's kind of hard, but this is something that I really want you guys to work on and know what you're doing. I think this really pulls everything together with what we're doing, and I think it's kind of fun. So it allows you to make your own decisions, whether something is perpendicular or whether you have a rectangle, parallelogram, rhombus, square, whatever. So hope you enjoyed this video. We'll see you soon. Thanks a lot. Bye.